Section 8.3, example 2. So before we start example 2, let's go through the steps for finding a confidence interval for mu, or the mean. So the requirement, just like before, x bar must be normally distributed. So the rules were it had to meet at least one of the following conditions. So if the population is normal, then x bar is normal. Otherwise, if we don't know that, we just need a large enough sample size. And so a large sample would be n at least 30, or at least 15 if the data is not severely skewed. So we could use a graph to check that. To check normal distribution, we could use norm test from 6.5. We'll see that a little bit later. So the steps. So if we want to find a confidence interval, we're going to go ahead and find x bar and s. That's coming from one var stat. We've done that a lot. We're going to sketch a normal curve and use the tails to find the t-score. So that's coming from the table with degrees of freedom. And then we can go ahead and find a confidence interval. So it'll be x bar plus or minus t times s over root n. And now that we're talking about averages, rather than saying p is an element of, we'll say mu is in the interval, because we're estimating the true mean. So example 2, we have a statistics class wants to estimate the height of all male students at their college. So they get a sample of 35 male students playing basketball in the gym one afternoon. So even though n is at least 30, right, it's 35 students, what's problematic about finding a confidence interval? The problem is this sample is not random. Why is it not random? Because they went to the gym and found males playing basketball. That does not represent all male students, so it's not representative. So the average might be maybe too tall, right? Athletes tend to be a little taller. Not that that's always true, but the average might be a little too tall. It wouldn't be representative of all male students. So let's do an example of a confidence interval. So example 3, we want to estimate the mean or the average, so we're in mean land and no proportions, of all western rattlesnakes. So 14 such rattlesnakes are randomly selected, so random is good, and my sample size is 14, and their lengths in inches are as follows. So let's comment on the requirements before we do any math. So my sample size is only 14, which doesn't even make the 15 cutoff. So we need at least 30, or we need 15 if it's not skewed. It makes neither of those, so we need the population to be normal. Since this is stats class, we're just gonna hope in real life, maybe we'd investigate, but I must hope that the population is normally distributed, so that x bar will also be normally distributed. If we were on the computer, we'd maybe do norm test. We'll see that maybe in a stats project or in later examples, but we'll just hope for now. So let's go ahead and do a confidence interval. Let's find a 90% confidence interval for the mean, meaning no proportions, we're in mean land, mean length of all western rattlesnakes. So let's go ahead and do one var stat to find the mean and standard deviation. So I'm going to go ahead and enter the data into L1. So stat edit, right, we haven't done this in a while, but stat edit, and then just type everything into L1. So I'm going to type a little fast, pause the video if you need to go get your calculator or you're typing a little slower. But make sure you type all 14 of them, and then we can use this for a check. I am typing this incorrectly. So keep typing. We'll learn how to check for typos in a second. All right, hopefully I have all 14. And we'll go to stat, calc, one var stats, L1. Right, make sure you tell it to look at L1. And then the sum of x squareds doesn't really have any meaning, but we can at least check that that's there. That's just to check for typos. It looks like I didn't make a typo. So my X bar is 42.44. I usually do one more decimal place than the data. And then my S is 2.1457. And I like to do 5 digits. So I'll remind you of that. So the mean is one more decimal place than data. And then standard deviation is just 5 digits always. So the idea is that rattlesnakes are probably near an average of 42.44, but it's probably not exact. So let's figure out how close we should be to 42.44. So we're going to go ahead and do a 99% confidence interval. So we're going to put 99% in the middle. Oh, sorry, it was 90. Yeah. Which means we do 0.5 on each side. This is a T-curve. Anytime we use means, it's a T-curve. It looks the same as Z, but we need degrees of freedom. So it'll be 14 minus 1 or 13. So we're going to go over to the T-table. We're going to go to the 0.5 column, and we'll go down to 13. And they meet at 1771. So that's my T-score. So you go to the column for the percent and the row for degrees of freedom. And now we have everything we need for the formula. So we're in mean land, so the formula for means is X bar plus or minus T times S over root N. So the mean is 42.44 plus or minus 1.771 times 2.1457 for S, all over square root 14. So we will get 42.44 plus or minus, let's find that piece on the calculator. And it looks, I get plus or minus 1.02. 0.15 will round up to 1.02. I usually just do the same decimal places as the first part, make them match. And then we can get an interval. So this is saying we should be above or below by about 1. So 42.44 minus 1.02 and 42.44 plus 1.02. And so since we're in mean land, we'll use mu, not p. So the mean is in the interval 41.42 up to 43.46. So we are 90% confident that the true length, or the true mean, I guess I didn't leave room for both, so we'll just say the mean length of all rattlesnakes. So the average, this isn't the length of a single rattlesnake, this is the length of the average of all, is somewhere in between these two numbers, is somewhere between 41.42 and 43.46 inches. So that's the average. There's easily a rattlesnake that's only 40 inches. There's easily a rattlesnake that's 45 inches, right? But the average is somewhere in this interval. So can we say with 90% confidence that the mean length is greater than 40 inches? So again, not a single rattlesnake, but the average. So my interval is telling me anything between 41.42 and 43.46 is a reasonable possibility. 40 will be out here. Is that whole interval bigger than 40? Yeah. So I'm definitely confident that the average is longer than 40 because the average is somewhere between 41.42 and 43.46. So yes, because the entire interval is bigger than 40. In math notation, will just be parentheses 41.42, comma 43.46. That whole thing is greater than 40.